Hey Technostuds! When it comes to encryption, there's symmetric and asymmetric ciphers. So in this video, let's cover what the difference is between symmetric and asymmetric encryption is. When it comes to cryptography, there's hashing algorithms and there's encryption. Hashing is that one-way function that gets that fingerprint, versus encryption is something that can be decrypted later. Within encryption, there are symmetric keys and there are asymmetric keys. So what we're going to talk about in this video is the difference between the symmetric keys and asymmetric keys. The name really does say it all. Symmetric just means something's the same on both sides. So in this example right here, we see that the keys are exactly the same. So if these two people were communicating, they would be using the same keys to encrypt and decrypt that message. Asymmetric means that there's actually a difference between the two keys that the two users are using, that it's not the same on both sides. And so this is asymmetric encryption. Asymmetric cryptography is the same as public key cryptography. You can think of them as the same thing. So public key cryptography, what is it? Well, there is a public key versus a private key. So a private key is meant to be private, that no one else can have, versus the public key can be sent out and anybody can see the public key. The public key can encrypt a message and send it to the private key, when the private key can decrypt it. Or the private key could encrypt a message and the public key decrypt that message. So what is the differences between symmetric and asymmetric encryption? Well, as one that we said is the symmetric has the same key on both sides versus asymmetric are different keys. But because of the way the different technologies work and how things are calculated, the symmetric key can be shorter where the asymmetric key has to be longer for the same level of security. So a 120-bit symmetric encryption would be roughly the equivalent of 3072 bits with an asymmetric algorithm. So the symmetric can be much smaller and shorter. 128 bits I'd say is the minimum. Up to 256 is pretty good in today's standards at least. And then versus asymmetric is 512 to 4096. So the symmetric, because they're shorter, it's much less intensive on your resources versus the asymmetric is much more intensive and takes a lot more CPU power to figure things out. So it's faster to process symmetric and slower to process asymmetric. So that's one consideration when you're selecting, do you want something that's symmetric or asymmetric? And then this can do bulk data versus this is usually used to establish a shared key. And what it means when asymmetric is used to create a shared key is because asymmetric takes so much longer to process than symmetric keys that what we do is we use asymmetric keys to establish a connection and then share a key that will then be a symmetric encryption after that. So you can see some of the values here and what the differences are. 80 is 1024 bits with asymmetric, 112 bits is 2048, 128 bits is 3072. So significantly more bits that are needed for this asymmetric, which is why it takes so much longer to calculate the asymmetric. One question that might come up is why even use public key cryptography at all? And the answer to that is because a lot of times, how do you share a key between you and a web server and create a secure communication, not ever having associated with that web server before? Maybe you're browsing the internet and you've never gone to that web server before. And so there needs to be a mechanism to encrypt that communication back and forth before you've ever even spoken. And then you can share a key and then move to that symmetric encryption. So that's where public key cryptography really shines and really is used a lot out there.